Welcome to our video on cloud and sea classification using AI models. In this video, we will walk you through the code that processes Sentinel-3 satellite data, trains various AI models, and evaluates their performance. First, we mount Google Drive to access the dataset. This is done using Google Colab's drive.mount function, allowing us to read and write files from our drive. Next, we combine all datasets into a NumPy file. We install necessary packages like netcdf4 and basemap. These packages help in handling netcdf files and mapping data, respectively. We define a function to convert netcdf files, .nc, to NumPy arrays, .npy. This function reads the .nc file, processes it, and saves the output as a .npi file. It handles missing values and prints basic statistics like max, min, and mean of the data. We split the dataset into 5 chunks for easier processing and storage. Each chunk is saved separately, allowing us to work with smaller, more manageable pieces of data. The next step involves loading the data and splitting it into chunks. We visualize each chunk to ensure the data is correctly processed. This step helps in understanding the data structure and identifying any anomalies. We generate training and testing datasets by selecting regions of interest from the data. We read mask files to create binary masks, which are used to label the data. We extract patches from the data and match them with their corresponding labels. To balance the dataset, we sample equal numbers of each class. This ensures the models are trained on a balanced set of examples, improving their performance and reliability. We save the balanced training and testing datasets for use in model training. This step ensures that the processed data is readily available for subsequent steps. We load the saved training and testing datasets. This is crucial for model training and evaluation, ensuring we use the same data across different runs and models. We define and train a convolutional neural network, CNN model. The CNN is compiled with the Atom optimizer and trained on the balanced dataset. After training, we evaluate the model's accuracy on the test set and save the trained model. We train a random forest classifier, reshaping the data to fit the model's requirements. The model is evaluated using precision, recall, and F1 score metrics. We save the trained random forest model for future use. Next, we implement Gaussian naive Bayes for classification. The model is trained and evaluated similarly to the previous models. The results are saved and visualized. We apply a Gaussian mixture model for classification. This model is evaluated on the test data, and its performance metrics are recorded and visualized. We use k-means clustering to classify the data. The model's performance is evaluated and compared with other models. The results are saved and visualized for analysis. Finally, we implement vision transformers, VIT, for classification. This involves defining a patch extraction layer and a patch encoder. The model is trained and evaluated, and the results are saved and visualized. In conclusion, this code provides a comprehensive workflow for processing Sentinel-3 satellite data, training various AI models, and evaluating their performance. By comparing different models, we gain insights into their strengths and limitations in cloud and sea classification. My project generally meets the requirements for ocean and cloud classification. However, it does not accurately distinguish between glaciers, sea ice, and clouds. Thank you for watching. We hope this video helps you understand the steps involved in processing and analyzing satellite data using AI models.